Hi everyone. Today we are going to learn work, energy and power chapter. Today's goal is to solve the given problem. Let's start it. In which case work is not done. A girl swimming in a pond, a windmill lifting water from a well, a standing man holding a suitcase in his hand, a sailing boat moving in the direction of wind. Here, holding, so a man standing holding a suitcase on his head. So he applied a force in the upward direction. So, but there is no displacement of the box. That's why the work done by standing man is equal to 0. My dear children, already you know very well, when work is said to be done means when a force produces some displacement, some displacement on the body, then only work is said to be done. Here option 3 is the right answer. In this situation, work is not done. Then go to second question. A boy holds a 40 Newton weight at arm's length for 10 seconds. His arm is 1.5 meter above the ground. The work done by the force of the boy on the weight while he is holding, same question, while he is holding it is. So here boy is holding the box. Here also the displacement of the box is 0. So work done by the force of the boy on the weight is 0 joule. Option 1 is the right answer. Let's go to third question. The work done on an object does not depend upon the, already we know very well, work is equal to force dot S, because work is a scalar quantity. If two vectors are multiplied, the product is scalar, then put dot between two vectors. So work equal to F dot S. So work done depends on displacement S and force S. If you remove the dot, then write work in scalar form, that is magnitude of S and cos theta. Theta is the angle between force and displacement. If angle changes, the work done also changes. So work done depends on angle between force and displacement. Then work done does not depend on initial velocity of the object. So option 4 is the right answer. Next, fourth question. Work done in moving a 50 kg block through a horizontal distance of 10 meter by applying a force of 100 Newton, which makes an angle of 60 degrees with the horizontal. So work done in moving a 50 kg block, 50 kg block through a horizontal distance, of 10 meter by applying a force of 100 Newton, which makes an angle of 60 degrees with the horizontal. Then see here, this is the 100 Newton, it is making 60 degrees with the horizontal. Then see here, we know very well work done equal to F dot S. We can write work done equal to magnitude of S cos theta. So here force, magnitude of force is 100 Newton and displacement is 10 meter and cos 60. We know very well, my dear children, cos 60 means sin 30, that is 1 by 2. So that is 1 by 2, 2 1 2 5 100 into 5, that is equal to 500 joule. So 500 joule is the right answer. Option 3 is the right answer. Then go to fifth question. It's a graphical question. Force and displacement. Already we know very well, area under force and displacement graph gives work done. Area under force and displacement graph gives work done. So in this situation, here in this situation, side into side. Here this is 3 meter into this is 3 Newton plus this area is in the form of triangle. So area of triangle, half into base. Base 3 to 6, that is 3 meter. Height 0 to 3, that is 3 Newton. So 3 into 3, this is 9 joule plus 9 by 2, that is 4.5 joule, that is equal to 13.5 joule. 13.5 joule is the right answer. Next go to sixth question. There is a crate here. A crate moves 10 meter to the right on a horizontal surface as a woman pulls on it with a 10 Newton force. Rank the situations shown below according to the work done by her force least to greatest. Least to greatest. Already we know very well when force and displacement, when direction of force and direction of displacement are perpendicular to each other, in this situation work done equal to 0. That means this is the least work done. So in which situation? Option 3. Option 3 is the least one. Next here, when direction of force and direction of displacement are in same direction, in this situation theta is equal to 0, then work done is maximum, because cos 0 is a 1, it is a maximum value, so work done is maximum. That is a greatest one. So greatest one is 1, least one is 3, greatest one is 1, so in middle 2. So 3 to 1 are the correct answers. So option 4 is the right answer. Next go to seventh question. Seventh question. A sledge, including load, weighs 5,000 Newton. It is pulled on level snow by a dog team exerting a horizontal force on it. The coefficient of kinetic friction between sledge and snow is 0.05. How much work is done by the dog team pulling the sledge 100 meter at a constant speed? Here, a sledge, that means box loading, it has a weight of 500 Newton. So its weight is 500 Newton. Its weight is 500 Newton. So friction. So friction is equal to, already we know very well, mu, and mu is 0.05. N means normal reaction. In this situation normal reaction is equal to mg, that is equal to 0.05. So mg means nothing but weight, that is given directly 5,000 Newton. So point of a 2 gets cancelled. 50 into 5, that is 250 Newton. Friction is 250 and it is a kinetic friction. Between sledge and snow is kinetic friction, that is 250 Newton. How much work is done by the dog team? The dog team is pulling this sledge in this direction, but this sledge is moving with a constant speed. Constant speed means friction is 250 Newton, means this force is also should be 250 Newton. Then work done is equal to force into displacement, that is 250 into displacement is 1000 meter, that is equal to 25 into 10 to the power of 4 joule, that is equal to 2.5 into 10 to the power of 5 joule. So option 2 is the right answer. Then go to 8th question. How much work is done in ergs in pulling a box 2 meter across a tabletop with a force of 20 Newton in horizontal direction? Here box, it is pulling with a force of 20 Newton in horizontal direction. So force and displacement are in same direction. Say displacement 2 meter, the force and displacement same direction, W equal to Fs. Here F is 20 Newton and S is 2 meter, that is equal to 20 into 2, that is equal to 40 joule. Convert joule into egg. I we know 1 joule equal to 10 to the power of 7 x, then work done equal to 40 into 10 to the power of 7 erg. So option 3 is the right answer. So 8th one, option 3 is the right answer. Next go to 9th question. A body is acted upon by a force which is proportional to distance covered. That means here force depends on distance. If distance changes, force also changes. That means here force is variable. Force is variable. If variable force acts, then work done is equal to, that is work done is equal to F into ds. If F proportional to x, we can write F is equal to kx. Then write here under integration of kx dx. So from this k is constant, then that is x dx. Integration of x dx nothing but x square by 2. So here k is constant, 2 is constant. Then f proportional to x square. So work done proportional to x square. Option 2 is the right answer. Let's go to 10th question. 10th question. The angle between the direction of applied force and displacement for maximum. We know very well, for maximum work done means direction of force and direction of displacement are in same direction. Same direction means the angle between them is 0 degrees. So option 3 is the right answer. 11th one, option 3 is the right answer. Sorry, 10th one, option 3 is the right answer. Then go to 11th one. A force of 10 Newton displaces an object through 20 centimeter and does work of 1 joule in the process. Find the angle between the force and displacement. We know very well, work done is equal to magnitude of S and cos theta. So your work done is given 1 joule. 1 joule force is 10 Newton. Displacement is 20 centimeter. Convert into meter. In the place of centimeter, 1 by 100 meter into cos theta. Okay, na? Then this is 21 ja, 25 ja, 5 1 ja, 5 2 ja. 2 come this side, that is 1 by 2 equal to cos theta. 1 by 2 means that is cos 60. Cos 60 is equal to cos theta. Theta is equal to 60 degrees. So theta equal to 60 degrees. 11th one, option 1 is the right answer. In case of negative work, the angle between the force and displacement is, we know very well, when the work is negative means the force and displacement are in opposite direction. That is 180 degrees. Theta equal to 180 degrees. Next, 13th one. Work done is said to be positive when a force crosses displacement in its own direction. Direction about to apply force, the direction see, it is in its own direction. When direction of force and direction of displacement are in same direction, then only work is said to be positive. 14th question. A man with a box on his head is climbing up a ladder. The work done by the man on the box is. Here a man is with a box on his head. He applied a force F in upward direction and he is climbing up a ladder. That means the displacement of the box is also in the upward direction. So force and displacement are in same direction and the box has some displacement. So a work is done here and here both are in same direction. That means direction of force, direction of displacement are same direction. That work done is said to be positive. So here work done by the man on the box is positive. Then go to 15th question. Let's see a 15th question. A plot of velocity versus time is shown in figure. A single force acts on the body. The correct statement is. We know very well in velocity time graph, if slope is there, the slope of velocity time graph gives acceleration. And here the graph is a straight line. If a graph is a straight line, that acceleration is uniform. So here acceleration is uniform. Here also acceleration is uniform. But here theta is less than 90. This acceleration is positive. This acceleration is negative. And here in the region A to B, the graph is parallel to time axis. In this situation, velocity is constant. So acceleration is equal to 0. So correct statement. The correct statement, observe the correct statement. In moving from C to D, work done by the force on the body is positive. In moving from B to C, work done by the force on the body is positive. In moving from A to B, the body does work on the system. And fourth one, in moving from O to A, work is done by the body and is negative. So calculate here first O to A. O to A. We know very well acceleration is in the direction of force. Acceleration vector is in the direction of force vector, and velocity vector is in the direction of displacement vector. Displacement vector, here acceleration is positive, so force is also positive, and here velocity is positive, So displacement is also positive. So when force and displacement both are in positive, work done is also positive. So in moving from O to A, the work done is positive. Positive. So option 4 is the wrong one. Let's observe here A to B. Here A to B, acceleration is 0. Acceleration is 0 means work done is also 0 because body moves with constant velocity and body moves with constant velocity. Net force equal to 0. So work done is equal to 0. Next, B to C. B to C. Here B to C, acceleration is negative. If acceleration is negative, force is negative. But here velocity, force is negative. But here velocity is positive. So displacement is also positive. Then work done equal to force into displacement. Negative into positive. That is negative. In B to C, work done by the force and the body is negative. But option 2 is the wrong one. Let's go to C to D. Here C to D, in C to D, acceleration is negative. So force is negative. And in C to D, velocity is negative. So displacement is also negative. Okay now. So your force is negative, displacement is negative. Negative into negative. Work done is positive. So in moving from C to D, work done by the force and the body is positive. So option 1 is the right answer. Let's go to 16th one. No work is done when an object moves. When an object moves at 90 degrees to the direction of force. So option 4 is the right answer. Let's go to 17th. A girl is carrying a school bag of 3 kg mass on her back and moves 200 meters on a level road. The work done against the gravitational force will be. Here a girl is carrying 3 kg mass. 3 kg mass means 30 Newton weight and the girl is moving along a level road 200 meter. Then the work done against gravitational force. Work done against gravitational force equal to here weight mg, displacement h. That is 200 meter. See, wait a minute. The work done against the gravitational force. The work done against the gravitational force. Here, with respect to ground, the position of the girl is not changed. Not changed. Here, level road, but work done against gravity means with respect to ground, the position should change. Here, there is no change in position of the girl. So, work done against the gravitational force is 0. 0, 0. So, 0. Next, 18th question. When the force applied and the displacement of the body are inclined at 90 degrees with each other, then the work done is, when the work done is 0. So 18th one, option 3 is a 0. Next 19th, work done by a centripetal force. We know very well, centripetal force means the force which always changes the direction of velocity, direction of motion of the body, and it always acts towards the center of the circle. That force is centripetal force. And here see another the direction of displacement. Then work done by centripetal force is 0 because here the direction of force and direction of displacement are perpendicular to each other. That's why work done by centripetal force is 0. It is always 0. Next, 20. A body of mass m is moving in a circle. A body of mass m is moving in a circle of radius r with a constant speed v. The force in the body is mv square by r and is directed towards the center. What is the work done by this force in moving the body over the half of the circumference of the circle? This force is nothing but a centripetal force. Centripetal force. This force is nothing but a centripetal force. Already we know very well, work done by centripetal force is equal to 0. Whether the body covers half of the circumference circle, full circle and quarter circle, whatever that it doesn't matter. Work done by centripetal force is always 0. Why? Because the direction of force and direction of velocity are always perpendicular to each other. So work done by centripetal force is always 0. Then go to 21st question. A stone is tied to a string and while in a circular path. The work done by the stone is here along the string tension acts. This tension nothing but this tension provides the centripetal force. So here tension and displacement are perpendicular to each other. Then the work done on a stone is 0. Option 2 is the